Hello everybody, this is the week 12 video for CIS 150. What we're going to do this week is finish up the PowerPoint slides for loops. So we'll go ahead and finish up that entire chapter. We're not going to do a quiz on this. I don't think we'll do any more quizzes moving forward. We'll stick with the homework. So we'll have, I know I put the schedule out there for what we're going to do. We'll have a couple more homeworks and then a final exam. Final exam will be just like the midterm. There might be another extra credit review just like I did for the midterm, but we'll see on that. But like I said, what I want to do today is cover this chapter, and then also we will probably have a live lecture this week. Kind of just depends on when you're watching this. We might have already had it, or it might be coming up. But we'll do a live lecture this week so you guys can ask any questions about the homework that you might have. So go ahead and make a new project. I just called it Loops 02. So CIS 150 11-10-2020 Loops 02. And then I just want to jump into today's just going to be maybe 2 or 3 examples where you should be taking 30 minutes per example to try to figure out if you can solve this. And I know there's no way that I can test you on this, right, to see if you actually are pausing the video. But if you're not getting this aspect of problem solving, that's going to come back to hurt you, especially on the final exam and with these other homeworks. So make sure you're actually pausing the video and testing this out, okay? So on the slides, we stopped around here with the do-while loop. The do-while loop, it's interesting. It has purposes, but to me, it's just like the switch statement. A do-while loop executes just a little bit different than a while loop. And for those reasons, I typically do not use a do-while loop because it's the same thing with a switch. I can do everything with a while loop that I can with a do-while, but the reverse is not true. So I cannot do everything with a do-while that I want to do with a while. So the reason that this is different is because a do-while loop is a post-test loop. So what that means is that it executes the loop first and then the expression. So I want to do something while this expression is true. Okay. Note that there is a semicolon here, so this one does have a semicolon after it. What that means is that this statement, no matter what, will execute one time, even if this expression evaluates to false the first time. Okay. So what we're saying is do the expression and do the statement. While the expression is true, continue to do the statement until it's false. So the way that reads is even if the expression is false the first time, I'll execute the statement, the expression is false, and I'll come out. Okay. So here, what we're looking at is an example of how this post-test is different from a while loop. Okay, and the reason that it's different is because we're going to say int x is equal to 1, do something while x is less than 1. While x is less than 0. Is 1 less than 0? It's not. However, you're still going to execute this output statement one time. Then go down, you'll evaluate, is 1 less than 0? It's not, and then you'll kick out of the loop. You can get this same the way that we use a do-while loop is sometimes it can be for menu-driven programs. I can make a while loop work for a menu-driven program with a couple extra things added. However, if you wanted to do something that a while loop does and only execute something if it's true, that's harder to do when you're doing a do-while loop. Okay? So this here, it's looking at running a program again. Do you want to run this program again, yes or no? I'm going to give you an example today where I want you to do the same thing. Hey, run the program again. Run the program again. Do you want to, right? We'll ask the question, yes, 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 no, whatever it is, but we're not going to use a do-while, okay? We'll stop there for do-whiles, and then we'll go ahead and start to look at for loops, but I want to pull up Visual Studios and start with an example. So the first example that I want you to work on is, let me comment this here, ask the user to enter a word of any size. Display each letter of the word on a new line. Okay, so we'll just say some kind of example here. E.g., they enter in testing, we would get the output T E S T I N G. Okay, so pause the video, take 5-10 minutes somewhere. This one isn't too hard, and see if you can get this to work. All right, so hopefully you were able to get that done. If you weren't, let's try to break this down. So my first question might be to myself, if I were you, is if this word was a set size, say it had 5 letters, would you know what to do, yes or no? And I think the answer to that, I hope the answer to that is yes, that if this word, we said string word is equal to, let's just say it was 2 letters. If it was 2 letters, can you get that to work? I think the answer to that should be yes. Cout, and we would say word dot at 0 with an indel, cout word dot at 1 with an indel. This should display an H here and an I here. We can give it a run just to double test. But we should get each of the letters on a new line. And we do. If this helped trigger something, helped you understand something, pause the video again, right? Continue on and see if you can get this with this given information. But it's not that easy for us because what we're doing is we're saying that we want the user to key that word in, okay? And we'll say cout, enter a word with an indel. Remember last week when I said anytime that we're letting the user key something in or it's dynamic and we don't know the size of something, that means that we're most likely going to have a loop. Okay? And what we can do is we could use a couple different variables and say something like int length and then maybe something like int I. And hopefully this is starting to now sink in. Once again, if you need to pause the video and try to redo this yourself, do it. At this point, what I'll say is length is equal to word dot length. Get the length of the word. I know I need a loop. I might not know the condition yet, but I know I need a loop. I need a loop to cycle through every letter of the word. That sounds a little bit harder. You're saying I want to look at every letter in the word, cycle through every letter. What if I said cycle through every index of the letter? Does that help? Maybe we say I need to go from 0 up until where? So we'll say this. Cycle through the index of the word letter by letter. We said start at 0, and where do you want to end? Well, hopefully there's 2 answers bouncing around out there if people are following along. And one of them is either length or, hopefully, length minus 1. Why? Why does it have to be length minus 1? Well, it has to be length minus 1 because the index and the length of the word are off by 1. That's why. So let's see what I mean by that, okay? So at first, we know that we need to start this counter at 0. This will be my counter. And I'll say as long as I is less than the length, less than the length. That's the same as saying less than the length minus 1, right? The length minus 1. So all I'm saying is there are two ways to write this. While I is less than or equal to the length minus 1. I don't care how you do it. But the problem is when you don't have consistency in your code, you'll start giving me stuff like this or this. One of these will break and one of these will skip the last letter. If it's less than or equal to, it needs to be the length minus 1. Less than the length, okay? What I want to do is I just want to display every letter at that index. So I'll just say cout word dot at I with an indel. Last thing you need to do is increment your counter. Count up 0, 1, 2, 3, 4, all the way up until the length, less than the length. So let's go ahead and key in a value and make sure that this works. We'll just say hello, and we do get hello. Well, let's try it again. Just make sure that wasn't hard-coded. This is, oops, that won't work. This is long test. Enter. This is long test. Wouldn't work if I put a space in there because we're just using a simple cin statement. Okay? Hopefully, this makes sense, cycling through this letter by letter. Okay? Next thing I want to do is I want to look back at the PowerPoints and start to talk about the for loop. So the for loop is once again a very unique loop in the sense that we couldn't use this loop for continuing to use a program. So do you want to run the program again, yes or no? This loop wouldn't work for that. So I have a general rule of thumb of when I use a for loop and when I don't use one, and why I use a for loop over something else. Typically what I would do is what we just did. I would use a for loop for that. So cycling through an array, cycling through the indexes of a word, things like that. That's what I'm going to use a for loop for. So let's go on down, and it says useful for counter controlled loops. So incrementing something by 1 and then looking at it, right? Incrementing this I value by 1. So for, then you have an initialization with a semicolon. You have to have this semicolon. Then you have the test that actually is performed. Then the semicolon. And then the update. Then you have the statement that you would produce. Okay? You're going to want to use the blocks, not just the statement after it. Okay? So the way that this works is that the first thing it does is it performs the initialization. Perform this. Next, it evaluates the expression. If the expression is true, execute the statement. If it is false, jump out of the loop. After that, execute the update statement. Go back and reevaluate the test. This is our loop. If it's true, execute the statement. So we'll go from test to statement to update to test to statement to update to test to statement to break out of the loop. So how does this look? It looks something like this. And you won't see me write them like this. What you'll see me write instead is I will define the int value right here. You will start to do the same thing most likely. It's a counter. And someone could critique this and say, well, if you define it there, then it only exists in the for loop. That's fine. That's the only place I need that counter to exist, is in that for loop. Okay, I don't need it anywhere else. It's just going to be a simple counter. And I don't want random little counters sitting around all over in my code. Okay, so We jump in, we say int count is equal to 1. Start this count at 1. I say is 1 less than or equal to 5? It is. See out hello. Count plus plus. Add 1 to 1. That gives you 2. Is 2 less than or equal to 5? It is. See out hello. Add 1. That's 3. 3 less than or equal to 5? It is. See out hello. Make it 4. Is 4 less than or equal to 5? It is. See out hello. Make it 5. Is 5 less than or equal to 5? It is. See out hello. Increment to 6. Is 6 less than or equal to 5? It is not. Skip out of the loop. Okay? If it were me, I would mark this slide in my notes because this really helps understand how everything is happening, where it goes, where the tests are happening. Okay? What I want you to do is I want you to take this program that we just made and recreate it using a for loop. Do the same thing as above, creating a for loop. Or I guess I should say using a for loop. Okay? Take about 5 minutes to do this. Hopefully you're able to complete that one. But what we're looking at is we're going to need a for loop. Okay? And what I'm going to say is int I, and I'm going to start that counter at 0. And I'm going to say I is less than, as long as I is less than the length, I'll say I plus plus. Then all I need to do is say cout word dot at I with an indel. The reason that for loops I think work better for this is because you don't have to remember to put the I plus plus at the end. Right? It's easy to forget this, but if you try to forget it here, it's not going to work right. So let's go ahead and run this. Testing, and we do get testing. One thing to make sure when you are testing your program is to make sure that you get the last letter and the first letter. So in this example, to start this counter at 1, or even to start this counter at 1, would not work. I mean, there are ways to do it, and I'm sure someone will tell me that, well, you could start it at 1 and then decrement. Sure. I'm never going to follow that code. I would never understand what that does. I would never understand why you would do that. So, yeah, I mean, there are lots of ways to do this, but there are ways that are going to make your code look readable and understandable, and then there are ways that are going to make it where your code just, it's so hard to follow. So something that I always talk about in these classes is that most likely your first coding job, they're not going to have you work on your own standalone project. I've never had that. You're going to be reviewing someone else's code. So if someone's in here doing something where they're setting I equal to 1, but they're decrementing by 1 to get the index to be a 0, that's confusing. That's hard to read. If I'm reading someone's code like that, it frustrates me because I don't understand why they would do that. I always try to follow the phrase of keep it simple, stupid. Keep it as simple as possible. And I still fall into the part where I make it too complex, more complex than it needs to be. Okay, so that's my little bit of advice for the day. So go ahead, finish up this for loops. You can look here. This is a little more in-depth example. This is saying that you can have two values, x and y. Yeah, that's fine. You can start with two values there if you wanted to, and then you can also increment two values. One thing to remember for your homework is that you can decrement values. You don't have to always say plus plus. You can say minus minus. Okay. You can omit the initialization. I wouldn't do that. I don't hardly ever see anywhere people omit that. And then it just says you can declare the variables in the initialization, which this is typically how you will see me write them. Keeping a running total, I'll let you guys read that. Sentinel values. Sentinel values are just values that kind of stand out. Special value, they cannot be confused with a valid value. We use that on the homework as well. Enter -999 to exit. Deciding which loop to use, not very helpful slide. It kind of helps you out here. I don't ever use these. I use these to iterate through words or arrays, and then I use these to actually run the program based off of a condition. So like a game loop. While the player has not died, continue. While the user continues to press Y, continue the program. Nested loops. So nested loops can be a little bit complex. The way that this works for a nested loop is a nested loop is a loop inside of the body of another loop. Inner loop is inside, and they call the outer loop is the outside loop. So the way that this will work is you're going to say row is equal to 1. Is 1 less than or equal to 3? It is. Jump down here. You say columns is equal to 1. Is columns less than or equal to 3? It is. Okay, then do this. Where would you go next? Well, from here you have to go to here to increment columns. Say is 2 less than or equal to 3? It is. Jump to here. Go back to columns. Increment to 3. Is 3 less than or 3? It is. Jump to here. Go back and increment to 4. Is 4 less than or equal to 3? It's not. Where would you jump back to? You jump back to rows now. Increment rows to 2. Is 2 less than or equal to 3? It is. Well, now you jump and you redo this loop. The entire thing starting with columns is equal to 1. Kind of a niche thing in the sense of a for loop. But we will have nested loops, and that's the next program we will do. We'll have to have a nested loop. Okay. This here, the way that I show this is for what's called a 2D array, which we'll get to in the next chapter. So the question is how many times would this cycle through? Inner loop goes through all repetitions for each repetition of the outer loop. Inner loop repetitions complete sooner than the outer loop, and the total number of repetitions for the inner loop is the product of number of repetitions of the two loop. So you go from 1 up to 3, or you'd say 1 less than 3, 2 less than 3, 3 less than or equal to 3. It'd be 3 times 3. Okay? This is something I don't really want to cover right now, so we will come back to this, but we're not going to cover this right now. Okay? This is how we can read files, and I do not want to cover that right now. Like I said, we will cover that when we start with the next chapter. We'll kind of bounce back to here, but as it sits, we don't need to cover this right now. Okay? Breaking and continuing loops. This is something that is valid, but it's not valid in my class. So, can use break to terminate execution of a loop. Use sparingly, if at all. The second bullet point literally tells you that we should only use this some of the time. Makes code harder to understand and debug. So I think some of you can sit out there and say, man, he's a stickler. He doesn't let us use all the stuff. He only lets us use some of the stuff. I agree. Because you do not know how to use a break statement yet. You don't know where to put it. A break statement says break out of the loop. If that's the case, why not just make a Boolean and break out of it? A break is hard to follow. These are all rules that I also had to follow when I was in computer science. So it's not just that I'm making this stuff up. I was never allowed to use break statements either. So break statements are not allowed in this class. Okay? When used in an inner loop, terminates that loop only and goes back to the outer loop. So the question is if you have nested loops, which one would it break you out of? Okay? And then the continue statement, can use continue to go to end of loop and prepare for next repetition. We're not going to use that either. Use sparingly like break. Can make program logic hard to follow. It just makes it hard to understand if I hit this, where am I going in the loop? Will I go down to this chunk or this chunk? Okay, it's no different than the return 0 or return 1, whatever int value you're returning when we were looking at Hangman. You weren't allowed to do that either. Okay, there will be times, and I'll show you perfect examples of when you should use break. I will show you a perfect example of when to use break. But as it sits right now, for any of the homework that we have, there is no purpose. There's no need to do it. And if you say that's the only way you could figure it out, that's not true. It is not true. Okay? There are other ways to do this, and you cannot use a break or a continue statement. Okay? So let's jump back to this. And we will comment this out, and we'll also comment this out. And we'll kind of put some brackets around this. And the next thing we want to do is ask the user to enter a word. Replace all uppercase vowels with a dash. We'll just say this. Okay. Continue to ask the user to enter a word until they tell us to stop. And we'll say this. Y or Y is continue. And we'll say in or in is stop. So it would look something like this. Say enter any size word. Hello. Replace the capital E in the capital O. I key in a Z. Says that's invalid input. Try again. I key in a G. That's invalid input. I key in an uppercase Y. Says enter any size word. Testing. Replaces the capital E. Run again. I say H. I say Z. I say lowercase y. Another. Replaces the A. I key in an N. And it says bye. I would pause the video right here and try to run some of these tests that I did. My advice to you. Now in this I would probably make this an in-class assignment where I'd give you the rest of the class to work on this. Once you got it done, you'd be done for the day, and I'd give you 10 or 15 points for doing it. If you couldn't get it done, I'd probably give you some points for trying. What I'm trying to say is give yourself 30 to 40 minutes to do this. If you get it done, fine. Pull the video up and see my solution. Challenge yourself to get this done and then understand why my code works and where you went wrong. Okay? So pause the video. See if you can get this to work. Give yourself 40 minutes and I'll show you the solution. Okay, so this is a little bit harder of a problem. Okay, because there's just a lot going on. This is also an example of where you might want to use a do-while loop. Because at first you're going to continue the program because they decided to run it anyways. Then you'll check the condition to see if the condition was met, to see if you need to continue to run the program. Like I said, I personally do not run them that way because I like to use one specific thing that can be used in multiple scenarios, and a do-while loop does not do that. So what I'm going to do is just break this program down, and I'm going to say string word, and then I'm going to say int word length. Say cout. Enter a word. Enter any size word, and then we'll just go cin into word. You could have used getLine here if you want. I don't care. And then we will say that word length is equal to word dot length. And you don't have to use this. You could have just thrown this into some kind of if statement. And then I need some kind of loop, okay? In this loop, I'm going to say is see if the user wants to run the program, okay? At first, what I'm going to say is that because you have ran this program, because you have done this, I am going to assume that you want to run the program. And the way that I'm going to do that is say string run again and say that that is equal to a y. You chose to run the program. You double-clicked on the application. I assume you at least want to run it one time. Well, what does that look like? If you want to run again, I'll say run again is equal to the double quotes of y, or run again is equal to the double quotes, one equal sign, I need two, the uppercase of y. If it's either of those things, you must want to run my program. Well, what about error checking? Why do I need error checking yet? We're talking the first run. I'm not even asking you yet if you want to run again. We will handle that later. You have to be able to break this down. I will go on to do the error checking, but I'm not going to do it here. Okay? At this point, what's the next move? The next move is to cycle through all of the letters in the word. How would I do that? I'm going to say for int I is equal to 0. I is less than word length I plus plus. Well, I need to look at every single letter. Every single letter. I'll say if word dot at I is equal to uppercase A, and this needs to be word length, or word dot at I is equal to uppercase E. And this is where students sometimes get confused and they want to do too upper, too lower. You are overthinking it. All I asked you to do is tell me if there's an uppercase vowel. That is it. Can't we just hard code those in? Those are already predefined values in our alphabet. A, E, I, O, U. Just fill them in. Or word dot at I is equal to I, or O, or is equal to U. And you could tell it's yelling at me here. It doesn't like this because I accidentally put double quotes. It's got to be single quotes. It has to be single quotes because word dot at something returns you a char, not a string. And double quotes is a string. That's why. You can't compare a char with a string. So at this point, if you have gotten into this, what can we say? So we'll say this. See if the letter at position, we'll say at index I is an uppercase vowel. If we break into it, we'll say if the letter is an uppercase vowel, replace it with a dash. Well, if it is at this particular position, we know that position is I, word at I, we'll set it equal to a dash then. If we wanted to just test this, just to see if it worked, just print out the word. The issue is that students will do this. They'll come down here and then say this. Well, see out I. It doesn't matter where I put it, just see out word. with an indel. Let's see it with the replace dashes. This will not work. You have to know where to put this. It can't go in the if, and it can't go in the for. It has to go after that. If you put it in the for, you would see out the word however many times that word is long. Letters are in that word. If it was 5 letters long, you'd see out the word 5 times. That's not what we want. So we'll run this. Sorry, that was my email. Enter a size of any size word, H-E-L-L-O. And we do get it, but we have a problem. We have an infinite loop. Well, the problem is that we aren't asking yet. We did a test. We wanted to make sure that it did replace the O, and it did. But now we need to go on and ask the user if they want to run it again. Ask if they want to run the program again. See out. Let's say run again. And we will see in into run again. Now it gets tricky. It's tricky because we need to say, what do we want to do next? What do we want to do next? Well, what is valid input? What is invalid input? Valid input is uppercase Y, lowercase y, uppercase N, lowercase n. Those are the things we should be checking against. So I'll say while run again does not equal a Y, and this is where you're going to get confused. Because in English, we're going to say if it doesn't equal this, or this, or this, or this, continue. If it doesn't equal this, or this, or this. I said, English-wise, that's what we say. But that's not what you want. You don't want to use an or here. You do not want to use an or. And we'll cover that in a second. What you want to use is an and. If it doesn't equal this and this and this and this, then that means you gave me invalid input. And I'll cover that in a second. So we'll say run again. It's okay if this doesn't make sense at first. Why we have to use an and. And run again does not equal an end, and run again does not equal an end. Let's go through this. Let's look at this. Let's write a comment to ourselves. Check the user's input against all of the valid inputs. God, why do I keep inputter? Inputs. This needs to be and, 1 second, not or. Remember how and or will evaluate to true or false. What we want to see, we're trying to figure out what is it that we want to see, is if they did not give us a Y or an N, upper or lower. That's what I want to see. So I'm going to put that. What we want to see is, if they did not give us Y, N, or N. Okay, so let's do an example. Example. User enters Z. How does this evaluate? Run again Z does not equal Y. That's true, right? True. And Z does not equal uppercase Y. True. And Z does not equal N. True. And Z does not equal uppercase N. True. What does that evaluate to? Evaluates to true. We'll run it again. E.g., user enters Y. Y does not equal Y. True, because it's uppercase or lowercase. And uppercase Y does not equal uppercase Y. That is a false, because it does. And uppercase Y does not equal lowercase n. That's a true. And uppercase Y does not equal uppercase n. That is a true. True and false and true evaluates to false. Exit out of the loop because you did give me something valid. If you key in the ORs here, it will not work. If you made these ORs, it will not work. There might be ways to get this to work if it's equal, while it's equal to y, or y, or n. Sure, but the logic is just my whole program would change. So the way that I'm doing it, this is the way that it has to be executed. Okay, so while you're in here, if I am in this loop, or we'll say the user, get bad input. Well, what do I want to do? Cout, invalid input, try again. And then we'll just tell them what is valid. Y, n. Cin into run again. This is now where we'll have another loop. I'll continue to ask you until you give me y, or n. But we aren't done. The reason we aren't done is because we got to ask them for a new word. Well, you can't just come down here and say cout new word. You can't do that because what if they gave you an n? That does kick you out of the loop, but you'd ask them anyways. So what you have to do is you have to make sure if run again is equal to a y, or run again is equal to a y, then I need to ask for a word. Cout. Enter any size word. Cin into word. And then let's just go ahead and get the word length right now. We'll say word length is equal to word dot length. I agree. You don't have to tell me that you did it a different way. There are tons of ways to do this. I understand that. So you could take all of this code and put it right at the top. And now you don't have to do this here. I agree. This is just the way that I decided to solve this. Okay? At the end of all of this, we'll put cout by, because that is the end of this program's execution. We will run again, and we'll do some intense testing. Hello, we get that. H, Z, M, N. Bye. Good. Run it again. Testing. Replace the I. Good. Run again. Capital Y. Good. Good. Run again. Z. We'll just give it a lowercase a. No. We'll say lowercase y. Good. Z. Nothing happens. Invalid input. Run again. Invalid input. Run again. Y. Another. Replace the a. in, buy. We are good to go. If you got it to work in a different way, awesome. There are, like I said, we're at that point where, man, there are just lots of different solutions to get this stuff to work. So if you got it a different way, awesome. This is just the way that I would solve it for you guys, right? I mean, I think that's another thing too, is that I try to code it as if I am sitting in your seat. I'm not going to use all the knowledge that I have and then show stuff that doesn't even make sense. Okay? If you have any questions, send me an email. Like I said, we will have live lecture this week, but it just kind of depends on when you watch this video, if it's happened already or if it's going to happen. Make sure you're working on the homework. If you have any questions about that, let me know as well, and I'll see you guys in the next video.